Okay, loop statement is the most important programming structure. Basically, if you know how to use the condition statement and loop statement, you can solve almost every programming problem. At the end of these lectures, you'll be able to describe a program that requires a loop statement, explain how a for loop structure is operated. You can identify the break comment and its usage. Explain the difference between the for loop and the while statement. Finally, you can solve and design the programming task using a loop statement and if statement. For loop statement is a counted loop that we already knew how many times of the actions are repeated. An iterator or loop variable specifies how many times to repeat the action. So we can perform with different iterators or loop variable in the specified range. The format of the range is a vector, okay? That's important, vector, okay? Basically, the loop structure is used to repeat the same operation, some actions on the elements in the range. If a for loop is executed, an action is repeated n times, that is the same with number of element in range. Okay? So each element is assigned to the loop variable in order. Okay? The script is to do the action using the corresponding the loop variable in each iteration, because in each iteration loop variable is to change it. Here's the one form. The other form is the range is set to the 1 to n. What is this one, by the way? This one is row vector, right? Vector is the vector, right? Okay. The iterator is set to II. The common iterator in other programming language, even in the MATLAB, is I or J. But as I mentioned, I or J is a constant in MATLAB. We learned about in Module 1, right? So I use II as an iterator. However, you can use any variable name here. Okay? Any variable. Okay? In this structure, do something is repeated n time. In each time, II is incremented by 1. Okay? For instance, initially II is become a 1 and do something, and then go up, II is become a 2 until II is become n. Okay? So major difference between the structure 1 and 2 is second structure we use this II, the iterators, to access elements in another vector or matrices. Okay? Most case this become a index for another vector or matrices. Okay. Here is the simple example of the summing 1, 2, 3 and assign is the value to the sum v. Here's the script. Let's see how the script is operated. By the way, this arrow means this variable contained this value. Okay. Okay, line 1. assigns 0 to the sum v, right? And then line 2, and then go to the line 2. This is the loop structure. It's repeated how many times? 3 times, right? And then II initially set to the 1. Okay, so here sum v is still 0, II is 1. Okay, and then go to the action part, line 3. What is this action? Adding II to the sum v, right? So that is sum v is become a 1, right? Okay, go to the line 4, but again II is changed until this end variable in this range, right? So II is go to the line 2, II become a 2. Okay, 2. And then do this operation. So 2 is added to the sum v, and then sum v become a 3, II is become a 2, and then end and line 4, and then go back to the line 2, and then I become a 3. Okay. And then line 3 is added 3 to the sum v, then sum v become a 6, and then line 4 again, and then this code doesn't go back to the line 2 because II is become a 3, that is the and the value of the range vector. So no more vector in the range, and then go to the line 5. Okay, does it make this a process of the loop structure? But here, what is the II? II is also variable. Okay, variable. Okay, so at the end of this process in the workspace, there are 2 variables. One is a sum v, that is a 6, there is a II. Here's another example to sum up all elements in this vector. The logic of this script is to read each element's value in the vector and adding to those values to the sum v variable. Line 1 and 2 assigned as a vector, and sum v's are created and assigned its value. Vector and 0, initialized with a 0. And then line 3, II is become a 1. And then line 4, we read the value, we read element in a vector in the II location. But in this case, we read the value 2 and then add it to the sum v. So in this case, sum v, and then II become a 1, and then go back to the line 3, II is become a 2, then adding the 3 to the sum v, and then it become a 5, and then we repeat this process until II become a 4. So in the end, sum v become a 23. Okay, this is how to sum the value in vector. Okay, good. Okay, in the previous slide, I introduced the 2 syntax. This is how we design the loop statement in a 2 different way. Like a previous example, we set the range of the iteration to the index, and the iterators become an index for reading the value of the vector. Okay, but here in the previous example, I used this one as a 4, But better approach is to compute the number of a value using the numeric function of the vector. Okay? Or you can use the size function. Why? This is because later when you look at this code, no, not this one, maybe when you look at this code, it is not easy to understand the meaning of the for. I mean, this is a very simple example, but your code is getting longer and longer, and then you're using the many different loop structure. It's not easy to find out what is the for means, right? So basic recommendation is, in general recommendation is avoiding such a meaningless numbers in your code and replacing this number as like this variable. So if you see this variable, you realize, oh, this one is the size of the vector, right? This is the how we did. Here's another syntax. You can directly put this vector to the range. Okay. So this is structure and these are the same. This is the, I said vector, right? This range big vector, but this vector is the dot vector, this one. Okay. So you're evaluating the script like a value. Okay. And in this case, the iterator, this iterator is a val. Val itself is a value. It's a value or element in a vector. So how many times a loop is iterated? 4 times, right? And then each time is a value. This element is assigned to the value. The first iteration 2 is assigned to the value. Second iteration 3 is assigned to the value. So this value is keep adding to the sum v. So finally, sum v is the summation of the all value in the vector. Okay, both are working script, but I usually take this syntax because in most cases I should refer or read the vectors, the multiple vector inside of this for loop. So I prefer use this iterator as an index as another vectors or matrices. Okay. Okay, similar to the nested if statement, we can place a for loop statement in a for loop statement. This is called the nested for loop statement. The working process is that inner loop action is executed in its entirety for every value of the outer loop variable. Okay, this is very important to understand how this nested loop structure works. In our word, in this format, entire inner loop process is executed in every loop variable. Okay. Okay. You can get the idea how it works if you see this example. The question is how to sum all elements in the given matrix named mat1. They assign the sum value to the sum v. Okay. Line 1 and line 2 are created, mat1 and sum v, and then put the value. Now here's the thing. Line 3, II become a 1, right? II become a 1. And line 4, JJ become a 1. Okay? And then to read the value of the mat1 at the ii in jj location. That is the first row and column in mat1, right? Okay, so this is the value is a 2, so 2 is added to the sum v. Okay, and then go to line 6, and then go to the line 4, not the line 3, the line 4, and then jj become a 2. Okay, because as I mentioned, the inner loop process should be first completed in order to go to the line 3, in order to go to the outer loop. So jj is become a 2. Okay, and action at line 5 is executed, and then 8, right? Because ii is equal to 1, jj is equal to 2. That is the first row, column, right? First row and then column. That is this one, right? First row, column. 8 is added to the sum v. So sum v is the 10. Okay. Then go to the line 4 because the jj is still 2, right? So at line 4, jj become a 3. And ii is still the 1, right? And then read the value, first row, and then third column. That is a 7, right? And then 7 is added to the sum v. So sum v is 17, right? And then line 6. And then, what is the next process? Because, line 6, and then it does not go back, right? Because the jj is a 3, so go to the line 7, and ii is equal to 1 now, so we go back to the line 3. So ii is, and then go back to the line 3, ii become a 2. Okay, and ii become a 2, and then line 4, what is the jj? 1, because we start this inner loop process from the beginning. Okay, so jj is become a 1. Okay, so what is the value at the mat 1 to 1? That is this value. So 1 is added to the sum v, so that become 18. Okay, we repeat this process. Okay, but basically, see this, what is the ii indicate? That is the row, jj indicated column. So we are reading the value first like this order. Okay, once we finish the process of the first row, and then we move on to the second row. Okay, keep repeating this process until the jj become a 3. Jj become a 3, and then summing the last value to the sum v, and then go to the line 6. jj is equal to 3, and then the code does not go back, and then 7, ii is become a 2, ii is now is a 2, right? So code doesn't go back, so see end. Okay, then sum b is a 29. Okay, this is the sum of all element. Sum of all element. Okay, does it make sense? Okay, this is a very, very important Okay? Very, very important. Okay? If you don't understand this nested loop structure, you cannot solve any problem in the later lecture. Okay? This is a very important concept. Okay? Okay. So how to summing all the value in the matrix using the linear indexing? Okay? But in this case, we are using the subscript indexing, right? That's why we need the two value. But how can we change this code to support the linear indexing? It's a simple, okay? But in this case, how many element, right? How many element in this matrix, right? Okay, so 6, meaning that in the linear indexing, 1 is indicated this location. Oh no, this is completely wrong. Okay, so linear indexing 1, 2, 3, 4, 5, 6, right? This is the order. Do not be confused. Okay. This is the order. 1, 2, 3, 4, 5, 6, right? Column first and then row. No, row direction and then column. Okay. Okay. But here, how many index value do we need to access the value? Just a single. Okay. So the linear index values are ranged from the 1 to number of element. Okay. So we first find out the number of element, then assign those values to the mval, and then we are designing one single loop like this, and then read the value using the linear indexing. Okay. Okay. Does it make sense? Both are the exactly same operation. Okay, but this one is only use the one loop structure. This one is use the double loop, right? Okay. All right. When the computer stored the variable in the memory, computers find out the space that fit the variable that you define. Pre-allocation is to set aside enough memory for the vector or matrix to be stored in the computer memory. Okay? But what happens when we keep changing the variable size rather than pre-allocation? It is very inefficient because every time the computers find out the new space fit the variable. Okay. Actually, we already learned about the pre-allocation functions like 0, 1, I. These are the kind of the function to pre-allocate the size, meaning that we initialize the variable with this matrix or the vectors. Okay, I recommend that you pre-allocate a variable if you know the size of the variable using this function. Okay. Okay, let's take a look at the example. Okay. The question is how to sum all value in each row of the matrix and assign those values to the variable named rvec. The logic is to make the double, nested for loop structure and two iterator, right? II and the JJ. So read the value in the matrix 1. And then summation of the row value, assign those values to the rvec. Okay, that's the logic of this program. But what is the size of our vec here? That is 1 by 3 row vector, because there are 3 rows, right? As I recommended, if you already know the size of the RVec, you're going to initialize this RVec with this kind of the function. Okay, 0 function or 1 function. Then we make the nested loop structure. Okay, II is the row, JJ is the column. Okay, so in this case, I draw the two, oh, not this one. This one, right? 2, 8, 1, 3, 2, 3, right? II is equal to 1. Sum R is initialized 0, but these are the inside of the loop structure. And then what is this structure? Read the value II is a JJ. Here is II is equal to 1. JJ is 1 and 2. That is this location and this location. And then summing those values to the sum R. And then you're assigning those values to the R vector. And the first location, that is summing up all value of the first row. Okay, and then go back. II is become a 2, right? And then sum R is initialized with the 0 again. Why? Because we are adding the new summation for the second row. So II is become a 2. And then JJ is a 1, 2. That is this one, right? So 4 is assigned to the RVec. Okay? And then go up, so II is equal to 3. That is the third row. Okay? In the end, you will get this value in the RVec. Okay? Does it make sense? Okay. In this example, here's the question. What if we move to the here? You will get totally different result, right? So in this case, Mat1 II, so elements that keep adding to the sum R, right? So if you move to this line here outside of the loop structure, in the end, the sum R become a summation of all elements, right? And then this result is wrong, right? This is not a summation of each row. Okay, what did I do initially here? Initialize row vector, okay, right? But what happened? We do not initialize our vector in the beginning. Okay, we could write a script like this. Okay, no R back here. And then there's a script are same in here with summing up the first row. And then what is this one? RVec, first one, sum R. Adding the sum R value in the RVec 1. But here's a question. RVec is not created in the beginning, but here this is the script that RVec is initialized with the sum value 1. So that's why RVec is the scholar right now. Okay, and then go back here. II is become a 2, and then summation of the second row here. Okay, and then what's the process when the II is equal to 2? RVAC. You're running this script. Is it possible? Yes, right? Why? Go back to the module 2. Referring the location that doesn't exist is fine because we are this new value adding to those location. So once you complete this iteration when the II is equal to 2, all vectors become a 1 by 2. Okay? I'm just showing that our vector size keep changing, right? In the first iterations, our vector is a scalar. Second iteration, our vector is a 1 by 2. What about the third iteration, third outer iteration? II is equal to 3. And summation of the element, the third row, is assigned to the RVAC 3. RVAC become a 1 by 3, right? So RVAC, size of the RVAC is keep changing, right? You notice that this one is not recommended. But you know what? The many students write this script without initialize, without the variable initialization. Okay? But we will see the another pre-allocation example is a later slide. Okay? But here, so we can shorten the first script. Here, so we introduce some R, and is initialize some R, and then adding all the value in the row and assign the some R in the R vector, right? But in this case, we can directly conduct the summation between the RVAC and then element in the matrix. Okay? Because the RVAC is initialized is 0, right? So let's see those just one iteration. II's become a 1 here, and JJ become a 1. That's the element is a 2, right? 2 is directly added to the value in the R vector, and R vector in the first location, that is the summation of the first row, right? Okay, R vac 1 inside is the 2. Then and go back. II's become a 2, that is 8, right? 8 is directly added to the R vector II. Currently no. What is II? II is still the same R vector 1, right? Adding the 8 to the R vec, so R vec first become a 10. Does it make sense? I think it is okay with using either the first, this one and this one, but for me, I'm preferred this one. Okay, this will look much simpler. Okay, good. Now we are integrating the loop and then if statement. Okay, if you integrate the loop and if statement, you can make a very strong script and then you can solve every single problem. Okay, that's the very powerful, the structure. Okay, in the previous example, we performed the same operation for all elements, right? So here we conduct the same operation like this, right? But if we integrate the if statement, we can do selective process based on the condition assigned in the if statement. For example, here, in this case, if the condition is true, action is executed. But if a condition is false, action is ignored. Meaning that when we make the condition statement, we are using the loop variable. Okay? Depending on the loop variable, this action is activated or not. Okay? Let's see the example. Here's a simple example. Please change 1 to 5, 2 to 7, and the rest of the elements to 10 in a given vector named the vec. The logic of this problem is to access each element in the vec and then evaluate this condition and assign the new value to the vec. Okay? So basically 1, 2, rest, that's the condition, right? And then these are assigning this value, so action, right? Okay, so we can write a script like this. Okay, first we set the range of the iterator. That is, this one is n is 9. So I is equal to 1. We read the value of the first element. Okay, and then check if it is same as a 1 or 2 or rest. Okay, so depending on this condition statement, we can assign this 5, 7, 10 value to the corresponding location. Okay, does it make sense? Okay, what happens if you II is equal to 3, II is equal to 3, fact 3 is here is a 2, right? This one. Okay, so this condition is a false and go to the next condition. This condition is a true, so this action is executed. So in the end, your vector is modified as like this. Okay. Here, the interesting part is this one. Okay. This one is to check the equality. Okay. This is not an assignment structure. Okay. This one is the assignment. This structure is actually change the value in the vector. This one is just a condition statement. Okay. Do not confuse equality sign and equal sign. This one, equal sign is assignment sign. Okay. Okay, let's solve another example. If values satisfy this condition, or values are replaced with a new value. New value is the 10 or 5. Okay. The programming logic is to read the individual element in vector and then test the condition, this condition, to determine the what value assigned to 10 or 5. So the structure is exactly same with the previous example, but only condition statements are different. Okay. If the first we read the value and then assign the t-val and then evaluate this condition. Okay. If yes, replace the corresponding value with a 10, otherwise 5. Okay. So depending on the condition, you can assign the different value. Here's another example. Let's find out the value from a vector. Find all indexes. Indexes is a location. Okay, location. Of a vector where the 5s are located. Okay. So here, find out the index of the vector where 5 is located. 5 is located, what is this one? Condition, right? Okay. So programming, logic are similar to the previous problem, but I'll explain this. Okay. I don't think I explained this syntax before. This script is literally assigning empty vector to the LEC location variable. Okay, this is not removing the element. This one is just a simply empty vector is assigned to the location. Okay, so it's like the location is included nothing. Okay, but why we initialize with empty vector? Because we don't know how many 5 in the vector. Okay, if there's no 5, we can say that there's no 5 in the vector, so we can just simply adding the empty vector, then add a value, add the location value to this location vector. For instance, we can appending the location value to this location variable. Okay, let's see this structure. Okay, basically, the program logic is a similar read a value and then test the condition. What is the condition? The element is a 5 or not. If you have 5, we'll store those location to the location variable. Okay. So here's the, this one. What is this one? Concatenating or appending. Okay. Okay, so II's become a 1, 2. How many elements? 1, 2, 9, right? 1 to 9. But if you know II's from 1 to 1, II is equal to 1, condition is false because vector 1 is the 1, right? This one. Then skip this part and then go back. I is equal to 2. Vector 2 is a 5, the condition statement true. So we are perform this operation. Well, what are the inside of the location? So if you put this variable in the right hand side in the assignment statement, that is reading the value, right? Reading the value inside of the variable. That is empty, nothing. Okay, nothing. So location, comma 2. Okay. Basically, you can think of the concatenating between the empty and 2. Then it become a 2, right? Okay. What about the II become a 1, 2, 3, 4, 5, 6, 6. Okay. If II is a 6, location is the 2 when II is a 6, and then II is 6, the vector 6 is a 5, so condition is true, so you're conducting 6, right? What is the inside of the location? 2. So this become this one. Okay. Does it make sense? Okay. We can change this part in a various way. Okay. For instance, here Okay. This one is what is this part? We are referring the end plus one. It's like a new location. Okay. Next location of the end, right? So this process is appending II value. Okay, exactly same with this one. Okay, or we can introduce a count, another variable. So count is just counting. It's just this count is become like a index of your location. So see this. For instance, II is become a 2. I is become a 2. II is assigned to the count location. What is the count location now? It's a 1. And then increasing the count values. The count value is a 2. Next time II is equal to 6 location. And then you're assigning the 6 to the second location of the location, and then adding the 3. Okay, do you understand this logic? You know, the programming structure is the same, but only difference is how to add the location to the location variable. Okay, good. Okay, this one is a bit of the challenging topic. Challenging. Okay. As mentioned previous slide, the pre-allocation is recommended if we know the size of the variable. But the size of the location variable in here is unknown, right? Because we don't know how many 5 in the vector. So how to implement the pre-allocating idea here? Okay, that's the question. In general, you start to assign the maximum size of the vector. Okay, what is the maximum size of the location? That is the same with size of the vector, right? Okay, so we initialize the location with the size of the vector. Okay, then we added a count value similar to this one. Okay, this count variable is a count of how many locations in the location variable is used. Okay, this count is incrementally by the 1. Okay, when the element in the vector is the 5. So location is initialized with a 3, 4, 5, 6, 7, 8, 9, right? So in this case, the first location become a 2, I is equal to 6th, and then second location become a 6, right? And then I is equal to 9, this location become a 9, right? Okay, then we are execute this script. What is this one? Read the first to the count. Count is a 3. Okay, and then reading only this value assigned to the location. So basically, this process is the delete the unused element. Okay, this is the same with this script can also be written by the location count plus 1 and empty. Okay. Then location vector initialize with a n by 1 by 1 by 9, but this location vector is the 269 1 by 3 vector. Okay. This is the general method to address a pre-allocating issue when we don't know the size of the output vector. However, in actual program, this is a recommendation, it's a general recommendation, but in actual programming, I'm open to use this one. Okay, unless this n vector size is huge, because we hardly see the speed difference. I mean, the efficiency is almost the same if you're dealing with the small size n variable. Okay, but you know how to use this method for the case where the loop iteration size, this one is huge. Okay. Okay, good.